Hi, thanks for joining me today. I'm Mrs.D Math. We're going to be covering the surface area of pyramids in 7th grade math. If you missed our last video going over the surface area of prisms, you can go back and watch that, or the video before that where we talk about the differences between pyramids and prisms. So let's go ahead and get started. Today we're going to talk about how to find the surface area of a rectangular pyramid using a net. So let's just review real quick. This is a pyramid. It's a rectangular pyramid because the base is a rectangle and a pyramid has one base. So we can see that the other faces are all triangles. If I break this into a net, that just means I'm going to take my 3D image and unfold it and lay it down like a two-dimensional image so that I can see all of the sides laid out. And then I want to find the area of all of those sides. So we're going to start with identifying the base, and then we can identify our lateral faces. So once we have all this identified, we can then find the area of each part and then add it all together. But the first thing we do want to find is the lateral surface area. So the lateral surface area is just the lateral faces. That means all of the faces that do not include the base. In this case, it would be all of our green faces. So I'm going to find the area of all the triangles and add those together first. Now, I do need to recap. My area of a triangle is 1/2 base times height. And the base and the height are indicated by the right angle. So I can see here in this one at the very top that I have a right angle. And I can't tell based on what I'm given that this is a square base. So all sides are 6. So that means that all of the triangles, the base and height, are 6 by 4. That means I don't need this slanted side or the side length of my triangle. I just need the base and height. So 1/2, base is 6, height is 4. And in this case, I have 4 of them. So I'm going to multiply that times 4. Now what I can do before I do all of this multiplication and then divide by 2, I can actually take half of one of these numbers. So I'm going to take half of the 4. Since there's 4 of them, I'm just going to take half of that 4, and that's going to become a 2. So now I can go ahead and solve. It just simplifies my problem a little bit easier. It's not going to change my answer, and it would still be the correct answer if I did the multiplication first. So I have 6 times 4, which is 24, and then times 2, which is 48. So the area of all 4 of these triangles combined is 48. The other thing I could have done is I could have said 1/2 of 6 times 4, and that would be 12, and then 12 times 4, because there are 4 triangles. If each of these is 12 centimeters squared, each triangle has an area of 12, and there's 4 of them, I'm still going to get 48 centimeters squared. So there's my lateral surface area. Then to find the total surface area, I'm going to find the area of the base and add it on. So in this case, it is a square, which is 6 by 6, or I could say 6 squared, which is why we call it a square. So in either case, 6 times 6 is 36. There's only one of them. So there's my base, and I'm going to add that on to the 48 lateral surface area. And 36 plus 48 is going to equal 84 centimeters squared. So there's my total surface area, 84 centimeters squared. Now we're going to look at a rectangular pyramid again, but I don't have this one in the form of a prism, just the net. So we're going to try it here without our prism. I can see that my base here is in purple, and then I can bring up my lateral sides. So if I'm going to first find the lateral surface area, that means I'm just finding the area again of all of these green triangles going around the outside. Now I can see that this is not a square base. This time we have a rectangular base, which means the base of the triangles are not all the same. I can see that these two opposite of each other are going to be the same area, which means that the other two triangles opposite of each other are going to be the same area. So really we just need to find the area of two triangles, and then we need to double them both. So again, area of a triangle, 1/2, base times height. I'm going to start here at the top. So this one has a height of 8, and I can see that this side length is 5. So that would be 5 by 8. And I do know that there are 2 of them. Then I'm going to add on the area of the other 2 triangles, which I can see is 9 by 6. And there are 2 of those. So let's go ahead and simplify these a little bit. Again, I can go ahead and cancel out the half and the times 2 because those are opposites. So I have 5 times 8 is 40. Plus, again, cancel out your half and your times 2. 9 times 6 is 54. And then my last step here is going to be to add these together. So that's going to equal 94 feet squared. So there's my lateral surface area. Then if I need to find my total surface area, again, all I have to do is find the area of the base. In this case, it's a rectangle, so I'm just going to do 9 times 5, length times width, base times height, and that equals 45. And then I'm going to add that to 94 for the lateral surface area. So the total surface area of this rectangular pyramid is 139 feet squared. So now that we've looked at a couple of rectangular pyramids, let's look at a triangular pyramid. So in this case, I have my triangular pyramid. I'm going to pull up the net. It's not always going to be exact when it comes to your images, so just make sure you're paying attention to the numbers. Don't worry about the detail of the length of everything. So on our net, let's go ahead and indicate our base, and then we're also going to indicate the lateral surface area. So that would be all of the triangles around. This one is a triangular pyramid, so all of the faces are triangles. The way to indicate the base in this case is typically the one that it's going to be sitting on. In this case, we just made it a different color. So once you have this pyramid laid out as a net, the middle or the innermost triangle is usually your base. So let's go ahead and find the lateral surface area first. So that's going to be the 3 green triangles. Now in this case, it is not indicating enough information for me to think that these are not all the exact same. So I can tell that these are all going to be the same size triangles. Now you can see that these 3 at the bottom are connecting exactly the same. So I do know that these are all going to be the same size triangle, and I don't have to worry about different sizes. Which means for the lateral surface area, I'm going to find 1/2 base times height, so that would be 10 by 12, and there are 3 of them. Now I can't find half of 3 and make this easier on myself, but I can still find half of 10 or 12. I'm going to find half of 12, which is 6. So that does help me still to simplify my problem before I solve. And now I can do 10 times 6, which is 60, and 60 times 3, which is 180 inches squared. So there's my lateral surface area. Then I need to last add on the area of the base. So that would be 1/2, 10 times 12. Again, I'm going to go ahead and cancel out my 12 and make it a 6 because I'm going to take half of that before I solve. And then 10 times 6 is 60. Another way you could do this is just find the area of one triangle, since we know they're all the same, times it by 3 to get my lateral surface area, and then times that by 4 to get my total surface area. So I need to now add on the 180. So now the total surface area is going to equal 240 inches squared. So this one, because all of the triangles are the exact same size, it makes it a little bit easier to do the math. You don't have to do as much math, and there are multiple ways that you can solve that. Let's try another one with a triangular pyramid, and this time we do not have the prism, we just have the net. So we'll go ahead and label the base and label our lateral surface areas. Now, this one has a lot of numbers, a lot of right angles. So in this case, you kind of have to just take it one triangle at a time. And based on the information, since these are both 10, we can assume or know that this height of this one is also 12. So these two triangles are actually the same size. So let's go ahead and start with our lateral surface area. So I want to find the area of the 3 outer triangles. I'm going to start with the 2 that I know are the same. So that would be 1/2, base would be 10, height would be 12, and in this case there's only 2 of them. And then I want to add on the area of the triangle that is opposite of those at the bottom. So that would be 1/2, and in this case 16 by 12, and there's only 1 of them. So I'm going to go ahead and solve this part and add these together. So I'm going to take half of my 2, which is 1, and then 10 times 12 is 120, plus half of my 16, which is 8, and 8 times 12 is 96, and then I can add these together. So 120 plus 96 is going to equal 216 meters squared. So there's my lateral surface area. And then to find my total surface area, I need to find the area of the purple triangle in the middle, and then I need to add that to the lateral surface area. So I'm going to do 1/2. Now this purple one in the middle, the base is 16, the height is 6, and then I'm not going to double that because there's only 1 of them. So now I'm going to find half of 16, which is 8. 8 times 6 is 48, and then I'm going to add that to the 216. So I can see here my total surface area of this triangular pyramid is 264 meters squared. Thanks for joining me today for surface area of pyramids in 7th grade math. I'm Mrs. D Math. Have a great day. Bye.